All right, today we're going to do something really cool. We're going to build a prediction machine. We're starting with just one super simple equation, and then piece by piece, we're going to add to it until we've built an incredibly powerful tool for understanding the world. Let's get into it.
So here's the game plan. We'll start with the absolute basics, the core engine of regression. Then we'll start adding more dials to make it more accurate. After that, we'll install some switches so it can handle data that isn't a number, and then we'll get really clever and wire them up so they can interact with each other. And finally, for the big finale, we're going to upgrade the whole thing to predict probabilities, which is where you'll see the real power of this entire toolkit. Okay, first things first. Every great machine needs a solid foundation, a core engine. And for our prediction machine, that engine is the basic regression model. And this is it. This is the heart of our machine. It looks simple, right? But what this equation is saying is that we can predict some kind of outcome, y, let's say a house's price, using just one piece of information, x, like its square footage. So right now, x is the only dial on our machine. We turn that square footage dial up or down, and the machine spits out a price prediction. Simple as that. A single dial is a good start, but you and I both know a house's price depends on way more than just its size, right? To get better, more accurate predictions, we need to feed our machine more information. It's time to add more dials. And here's how we do it. We've just expanded our equation, adding more x variables. So now, along with square footage, which is x1, we can add a dial for the number of bedrooms. That's x2. And maybe one for the age of the house, x3. You see, each new dial gives the machine more context, more information, and that lets it fine-tune its prediction to get way, way closer to the real price. Okay, so our machine is getting pretty good with these dials, things we can measure, like square feet or the number of rooms. But what happens when the information we have isn't a number? I mean, for our house price example, what if we want to know if the house is in the city or out in the countryside? That's not really a dial you can turn. Exactly. That's the big question, isn't it? How does a machine that's built for numbers handle a simple category? You can't just plug the word city into an equation. We need a different tool, a new kind of component for our machine. And that trick is called a dummy variable. Honestly, the easiest way to think about it is as a simple on-off switch. We can just decide that 1 means city, so the switch is on, and 0 means rural, the switch is off. It's a really simple but brilliant way to translate a category into a number that our machine can finally understand. So how does this little switch actually plug into our equation? Well, you can see it right there, that new D term. That's our switch. It works right alongside our other dials, and what it does is modify the machine's baseline prediction, its starting point. So for example, it might tell the machine that all other things being equal, houses in the city just start at a higher price. And this table just breaks it down perfectly. Look, when our city switch D is off, set to 0, because the house is rural, that whole middle term just becomes 0 and disappears. We're right back to our original equation. But when that switch is on, when D is 1, it adds a fixed amount to the starting price, shifting the entire prediction upwards. It's such a simple idea, but wow, is it powerful. Our machine is getting seriously smart. It's got dials for size and age, and it's got a switch for location. But there's a catch. Right now, all those parts are working independently. The next big upgrade is to let them actually influence each other. I mean, think about this for a second. What if an extra bedroom adds, say, $20,000 to a house's price in the countryside, but it adds $100,000 in the city? The effect of the bedroom dial totally depends on whether that city switch is flipped on. That's what we call an interaction, and it happens all the time in the real world. So to capture this, we add something called an interaction term. Now that sounds complicated, but all we're really doing is multiplying our city switch D by our bedroom dial X. Just think about it. If the city switch is off, it's set to 0. So this whole new term becomes 0 and just vanishes. But if the switch is on, if it's set to 1, then this term activates, creating a whole new separate effect for bedrooms specifically in the city. This is how our machine starts to model those really complex, nuanced relationships. All right, deep breath. We're about to give our machine a totally new job. So far, it's been all about predicting a specific number, the price of a house. But what if we wanted to predict something different? What if we wanted to predict the chance that a house will sell within 30 days? That's not a price, that's a probability. It's a whole different kind of question. And this is the key difference right here. The machine we've been building so far, it uses linear regression. Its job is to predict any number on a scale. But to predict a probability, a number that absolutely has to be squeezed somewhere between 0% and 100%, we need a different type of model. And that's called logistic regression. Okay, I know what you're thinking. That formula looks a little terrifying. I get it, but hang on. Just ignore all the crazy stuff on the outside for a second and zoom in. Right there, inside the parentheses. Does that look familiar? It should. It's our good old linear equation, the same one we've been working with all along. All our dials and switches for house size, location, bedrooms, they're still right there at the very heart of it.
So here's all that's really happening, broken down into 3 simple steps. First, the machine calculates a number, just like it always has, using that linear core. Second, it takes that number and feeds it into that big, fancy formula on the outside, which basically acts like a special wrapper. And third, that wrapper function does one simple job. It squeezes the result, guaranteeing that the final output is always a clean probability between 0 and 1. That's it.
So let's just step back and look at what we've built. We started with this really basic machine that could only use a house's size to guess its price. But by adding just a few clever extensions, more dials, some switches, and interactions, we've turned it into a far more versatile and seriously powerful toolkit. This is our complete toolkit now. We learned to add more variables for much better accuracy. We used dummy variables to handle categories like city or rural. We created interaction terms to capture those complex, real-world relationships. And finally, we adapted the whole machine to predict probabilities. You see how each step was just a logical extension of the last one?
And this right here is the key takeaway from all of this. Starting with a simple model is just the beginning. The real power isn't just knowing that basic equation, it's knowing how to creatively add all these extensions, the dials, the switches, the interactions, to answer much more interesting and complex questions about the world. So, I'll leave you with this thought. Now that you have the blueprints for this prediction machine, from its basic engine all the way to its most advanced upgrades, what complex questions about your world, your work, or your passions could you start to answer with it? Thanks for joining me on The Explainer.